Okay, the first thing you do is you're going to create a velocity versus time graph. So the thing you want to do is do this on graph paper, which I don't have up here, but you know, velocity, meters per second. I'm just going to kind of give you a rough sketch of what this should look like. So here are your points. So the first data point is what? 0, 0. Hey, so scaling this out, here's how you do it. When you're scaling it out, you want to make sure that you use the majority of the y-axis and the majority of the x. So on the x is time. What's our largest time?
8.
8. The largest is 8. So we're going to go like this. We're going to go 1, 2, 3, 4, 5, 6, 7, 8. So 2, 4, 6, 8. Okay, what's the largest value on the y-axis? 20. So we want 20 to be up here somewhere. So let's see, we're going to go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. There we go. 4, 2, 4, 6. This is 8, 10. This is 12. This is 16. And then up here is 20. Okay? All right, so we plot the data points. So 1 second and 4. So this is 1, 4. So we got a point right there. There. So the next one is 2 and 4. So right there. The next one is 3 and 8. So 3 seconds and 8. So that's going to be right here. Then 4 and 16. Something like that. And then 5 and 20. And then the rest of them stay at 20. So the graph goes like this. It goes up, flat, up, right to that, flat. Okay, so that's roughly what your graph should look like. Okay, B, determine the distance the car travels during the first 2 seconds. So again, how do we find distance on a velocity time graph? Area under the graph. So we want the area in here. Now what do we have to do to this thing, to this area?
That would be a trapezoid.
You got how do you deal with this? You got to break it into what? Do a triangle. So I'm going to make that all dark. Triangle and a rectangle. So what's the area of that triangle? The area of the triangle? No, not 4. 2. The area of the triangle is 2. And then what's the area of that rectangle? 4. That's going to be 1 to, that's 4. So what's the total distance traveled from 0 to 2 seconds? 6 meters. Okay. Part C, what distance does the car travel during the first 4 seconds? So now you're going up to here. So now we want the area under the whole thing, dude. From 0, from here to there. So we already know from 0 to 2. So now we got to go from 2 to 4. So break this into a triangle. So I'm going to make the triangle nice and dark. So here's your triangle. And then what's sitting below the triangle? A rectangle, a square. It's 2, no, it's a, what is that, 2 and 4? Whatever, rectangle. So the area of that rectangle, the area of the rectangle is going to be 2 times 4, that's going to be 8. And then the area of the triangle is going to be 2 times, what's the height of that triangle? 12, it would be 24, so it's going to be 12 meters. The area of the triangle is 12.
Wait, isn't it 8?
Hold on, let me check it. The height of the triangle is 12, and then 12 times 2 is 24. Divide by 2, because no, it's 12. The area of the triangle is 12.
No, I mean the height. Because you start from 4.
Yeah, but it's from 4 to 16.
From 16.
From 4 to 16 is 12.
Oh.
Okay? And then the last question, what distance does it travel during the 8 seconds? So that now you're taking the area under the whole deal, right? Everything, okay? Which I'll let you guys do. Hey, you know what I noticed? What did I not ask? Those of you who are totally on your A game right now, what did I not ask on this velocity time graph, which I could ask on the quiz tomorrow? Acceleration. If I ask you to find acceleration on a velocity time graph, instead you're not looking at area. Acceleration is not area. Acceleration is the slope. It's the slope of the line. Okay? Okay.